Good evening, sir.
Yeah, good evening, Kushbul.
A very good evening to all. Welcome to day 5, 10 technical session of 6-day online faculty development program on electric vehicles and charging station technology for sustainable development sponsored by AICTE ATAL. And our resource person for this session is Ajit Kothari, sir. On behalf of organizing team, I welcome you, sir, in our today's technical session. Before you start your expert lecture, I would like to share a short biography of you to the participants. Ajit Kothari sir is working as Vice President of Product Development, having professional experience of 32 years in the design and development of power electronics equipment such as thyristor control rectifier, battery, energy storage systems for utility and CNI, battery packs of EV, stationary applications, renewable energy, solar converters and power transformers, voltage stabilizers, etc. Achievements in dealing with HP of 133 kV AC and 150 kV DV, SC of 30 k DC, HP of 5 megawatt at the individual equipment level. He worked with the various companies like Reliance Industries, Fuse Electric, Hind Rectifier, Edor Powertrons, Resins, RPG, etc. With this, I would expect our expert Ajit Kothari sir to kindly enlighten us with his word of wisdom. Sir, please.
Thank you, Kushbul Madam, once again for the nice introduction. Uh, so straight away, we'll start with our presentation on the BMS, smart BMS for EV. So I'll share my screen first. Hope my screen is visible to everyone.
Yes, sir, it is visible to us.
Yeah, thanks for coming. So, good evening all, and welcome back on the session of Smart Battery Management System for electrical vehicles. So, we have already gone through this session earlier also. So, I'll just brush you before again we start the same topic. So BMS, we earlier we gone through the BMS part of this. We try to understand what is BMS, what are the functions, the key component in the BMS, what are the functions of BMS, and then the major key functions of BMS also we went in detail, like the balancing, cell balancing, and the communication part of it. So again, we'll start with the definition of BMS. So BMS is generally used wherever the rechargeable battery packs using the lithium-ion battery or any other battery for the sake, BMS is must. So it is an electronic system that manages and monitors the performance of rechargeable battery, ensuring its safe and efficient operation. So this is the technical definition of BMS. BMS are used wherever you made any battery pack using the rechargeable batteries. So the battery pack is consisting of multiple cells connected in series and parallel, as you know. So to monitor the function, or you can say the reliability of, to ensure the reliability of that battery pack, this electronic circuit is required, which is monitoring individual cell voltage, then the battery pack current and individual cell temperature as well. And this is not only monitoring, it is computing all the, you can say the total charge of the battery pack, like SOC, the health of battery, that is SOH. So state of health we are saying, and SOC means state of charge. So the computation of SOC, SOH also done by BMS. Then the protection point of view, it is protecting the battery pack from getting overcharged, or the over voltage is connected to the battery pack, or the load is connected very high, or you can say the overloaded, so that it is not getting the battery packs are not getting damaged. So the primary function of BMS is to protect the battery pack, right? Yeah, 1 second. Sorry. Uh, so that is the purpose of the BMS, you can say. And the application wise, wherever, as I said, wherever rechargeable batteries are used, so in that system, BMS is must. The examples like EV, where battery packs are used for driving your vehicle. Another is the battery storage, energy storage system. So there also batteries are used. So BMS is again must. In case of portable devices like your laptop or your mobile or your wristwatch, so there also lithium batteries are used. So directly or indirectly, that BMS is inbuilt with the battery packs, right? So that is the application of BMS. Purpose already we discussed. So this is the block diagram of BMS. So the green color uh, blocks, what you are seeing here, uh, are the major, you can say, the blocks of your BMS. So the left side is the battery pack, consisting of a number of cells, N cells. They are connected either in series, parallel, or combination of series or parallel. So this is the complete battery pack of your system. Then the thermal temperature or the sensors are connected on each cell. The sensor voltage is connected to BMS measurement or measuring unit. The current of the total pack is sensed by CT or Hall effect sensor. So that sensor output is again connected to this measuring unit of BMS. And each cell voltage is also connected to the measuring unit of BMS. So these are the sensing circuits which are connected to BMS, which is monitoring all these temperature, measuring all the voltages, measuring current. Then this measurement unit is just means converting this analog signal into digital, and then there are other computation also inside the BMS, like state of charge, state of health is computed by these additional, you can say, the circuits, depending on how much this battery pack got charged with this current for how many times. So real-time data is again stored into the BMS memory. So one block of internal is the BMS memory. Also, in some devices, it is must. Like in case of base, where battery energy storage system is there, or in case of EV also, we have the internal memory where real-time data are saved for, and that data is useful whenever you have the problem with the battery pack. So to do the troubleshooting or to understand what exactly happened in the battery pack, or the in some cases to understand what is your load pattern or how you are loading your batteries. So that data is very, very important in case of doing the analysis of your battery pack, uh, how it is performing, whether it is giving the required load, or what is the demand from the load side. So all data, whatever parameters it is measuring, it is getting stored into the internal memory of the BMS. So that is not must in all the BMS, but nowadays it is required for EV and then the BESS. So this data is not required for your, you can say, the application like your mobile or laptop. So in laptop also, some history is stored, like for a day or two. That data is stored in some of the devices, right? So these are the major blocks. Then thermal management system is there, which is monitoring this temperature continuously. And then we have the set point inside the thermal management system where some reference data are stored for a protection point of view. Let's say we have set a cutoff voltage or the cutoff temperature of cell at 60 degrees Celsius. So this device will continuously monitor your cell voltage or cell temperature in that case. And with reference to this set point, it will continuously monitoring it, and it will keep this BMS working till that temperature, set temperature. If it is exceeding or coming to near to that, we have 2 or 3 alarms also. If let's say our set point is 60 degrees Celsius, maybe 2 degree below, it will start giving command like your batteries are getting overheated. Then maybe at 60, it will give you the continuous beep or the alarm that your battery pack is going to be switched off now because of the over temperature, so that you will be ready with your whatever vehicle. If you are driving, you can take your vehicle to the safe side, or maybe within 2 or 3 minutes you should take your vehicle to the standstill to avoid the sudden breakdown or sudden stoppage of your vehicle. So that timing is always there, given, or warning sufficient time is given to the user also. So that is the purpose of your thermal management system. So it is not immediately turning off the battery pack. So we have 2 or 3 stages of warnings. So these are the basic functions of your BMS. Then the another major function is the cell balancing. So cell balancing is again there in the battery pack, which is monitoring all the voltages are monitored by this measurement unit. And then depending on the charge, state of charge of each cell, it will try to balance all the cells at one level. Then again, this whatever data is available, or the computed data, thermal management system, whatever warning signals are there, all these are available at the CAN bus. So the external control system, this information is given to the external control system, where user will have the dashboard kind of thing. So all these data will be either directly given by BMS, or in case of your EV, VCO will be receiving all this data, and it will means produce, or it will be used, that data will be used to indicate on the dashboard. So all warnings, or whatever important data are there, like state of charge is important, then the warnings are important. So that information is passed on to the what you call the dashboard of your vehicle. So this is the main, you can say, the block diagram and functions of each block inside the BMS. Now, we understood what is there inside the BMS. So we'll try to go in detail about the key functions and working of each block inside the BMS. So as we discussed, this monitoring. So BMS is monitoring all the voltages of all the cells. Let's say a battery pack of 12 cells is there. So the BMS will have 12 inputs from the cell. So every cell will be measured with the BMS. So it is keeping track of voltage of each cell. Then temperature of individual cell or maybe the important cell from this 12 pack, uh, 12 cell battery pack, maybe one or two cell yeah, where more heat is generated. So that cell also we are monitoring. Either in case of base, it is compulsory to monitor all the cell. In case of EV, it is two or three cells, critical cells we are monitoring. So that way we can reduce the hardware requirement of BMS. Then the current flowing through the battery pack. So these are three parameters which we are monitoring continuously or sense from the battery pack. Then SOC and SOH is the computed parameter, which is output of all these three with respect to your time. So the time and these three parameters will give you the SOC and SOH of the battery pack. So it is inside algorithm is there for every battery pack we have tested, and then the algorithm wise it will give the accurate SOC of the battery pack. So the accuracy level is up to the level of 99%. So you can rely on whatever data is shown on the dashboard. Uh, this was related to monitoring. Now the protection. Protection ensures the battery operates with the within the safe limits of design parameters. Let's say we have designed the battery pack with some uh, charging voltage, or we have to protect the battery going fully discharged. So under voltage protection will be there, over voltage protection will be there, so that your batteries are not getting charged with high voltage. So that way, these battery packs are protected from the voltage point of view. In case of current, again, it is monitoring the charging current or discharging current, and it will protect your battery pack from getting it overcharged or by more current, or in case of short circuit, also it is protecting the battery pack. Uh, then overheating, that is again because of maybe unsafe the conditions, or you can say in case of EV, if you are driving at a very high speed or at a very high temperature, ambient temperature. In that case, let's say you are exceeding the design temperature of that particular vehicle or battery pack. In that case, the temperature of cells again will increase, right? So the BMS is protecting from that over temperature by cutting off your device, or in this case it is EV or your vehicle. Your vehicle will get stopped, so that loading will get stopped at least. So cell will go into the standalone, or you can say the storage state, where load is zero, but still the temperature of that cell is high. But whenever temperature is going down, you can keep your cell maybe 5 or 10 degree more if load is not there. So storage temperature of that particular cell is high compared to when it is connected to the load. So that is how it is protecting the cell from over temperature. Balancing and communication we'll discuss in detail in the later slides. But just to understand what is balancing, so here we are maintaining our BMS is maintaining or trying to maintain the equal charge in all the cells, whatever used in that particular battery pack. So that is the function of your BMS. Uh, right? Communication, again, as I said, whatever data is there, real-time data is there, that is communicated to the external system for user understanding or for user purpose, whether it is protection or faults or real-time data, whatever is required by the user, it is communicated through the whatever CAN bus is connected to the BMS. So all data, whatever is there inside, it is available always for the user to access it through CAN bus, and that data is used to diagnose in case of any problem is there, or if you want to study the performance of battery pack, how it is behaving in case of over demand from the load side, or how your driving skills are there. uh, that also can be studied by the OEM. So these data are very important from OEM point of view. Whenever they are initially when they are giving this, you can say the vehicle to for test riding. So that data uh, is analyzed by the battery design engineers. In case of hill region, how much current it is drawing. In case of sudden break, what is the condition of your battery, whether it is getting sudden jerk or so other, all the parameters which are useful for you understanding of your performance of your battery pack is always available for the designer as well as the user also in some cases. So all data, it is not necessarily given to the user, but in case of troubleshooting, again, the service engineer of that battery pack, he needs to understand the behavior or how you loaded your battery, how you charge your battery, how you discharge your battery. So from that data, he will try to understand whether guarantee is void, or it is I mean, it's not in the guarantee period, because if your performance of again, it depends how you are using your battery. So if your temperature is continuously high, then the manufacturer of battery can tell you that you are always in the high temperature zone. So the what you call the guarantee may not be given in that case. So all these data, whatever real data are available inside the battery pack, are used for these purpose also. Okay, so now we'll see how it is the outgoing data from BMS to external system is given. So as I said, SOC, SOH is given to the external system. Then individual cell voltage or a pack voltage. In some cases, cell voltage is not required. Then the total battery voltage is given to the external system. Let's say if that battery pack is of 12 volt or 24 volt, then the total voltage of that battery pack will be given to the VCU in case of EV. So EV VCU doesn't need a single cell voltage. So they will take only the pack voltage, and cell voltage will be stored inside the BMS. Then the charging current and discharging current, that is also again, it is a part of communication. If it is required in case of VCU, uh, discharging current is not that important in case of VCU, but for battery it is always to be monitored. So during charging, again, it is required because you cannot charge this battery pack over the stipulated current. So battery will take the maximum current what is available and which is within the limit of your battery, safe limit of your batteries. Then the temperature readings also can be given to the external system where continuous temperature is monitored and given to the system. And that readings can be used for giving the warning to the user also. And then fault or warnings, for example, over voltage, over temperature, so or whatever malfunctioning of your battery pack because of all these parameters are also given to the external system so that user will come to know what exactly happening in the system. So these are the important parameters which are given to the outside or the external system. Now, what data BMS is taking from the external system? So here, in case of charging or discharging commands, so handshaking signals are there to start the battery pack. So initial commands will come from the charger, or you can say the VCU in case of EV. Then the EMS will again get some data from your charger also, at what voltage or what current it is charging the battery. So first the data from the BMS is communicated to the charger, and then charger will accept that data and charger will again communicate to the BMS, like this is the parameter or this is the charging parameters at what battery is going to be charged. So all this information is given to the BMS as a input data. So thermal management control signals, again, it can be input signal also from the external system where it is trying to measure what is the outside temperature uh, of the ambient. So that again signal can be given either by the charger or the vehicle. So these are the external signals given to the BMS. And then the configuration setting, like as I said, the charging voltage and current, the charger will communicate to the BMS as an input data. So these are the parameters which are input and output, uh, means used for communication purpose. Now we'll go in specifically application wise. We'll try to understand what is the importance of your communication. So in case of EV, as I said, it is giving the complete data or the important data of the battery pack to the VCU, that is vehicle control unit, where from VCU point of view or from user point of view, SOC is very important data. So it is communicating how much charge is available inside the battery. So indirectly it will give you, or directly it will give you the mileage, or you can say the kilometer left into the vehicle or into the battery, or the energy is available into the battery, and then you can calculate how many kilometers you want to go, whether that charge is sufficient or not, whether you need a full charge of battery, or whatever charge is available is sufficient to take that vehicle outside and come back. So as per that calculation, you can uh, means that data is useful to the user before starting off your vehicle or before you start your journey. So SOC is very important. Then the charging station, again, the safe, whatever efficient charging data is required, that again communicated to the charger. So these are the important data communicated to in the EV application. So in case of the energy storage system, again, this is similar to your EV, but here the data management is little bit different. Here, instead of kilometer, uh, the data is important is the how much charge is available, or in you can say how much kilowatt of energy is available inside the battery pack. So instead of giving you kilometer range, it will give you the charge in kilowatt hour available with the battery bank. So it is nothing but the SOC available with the battery. So how much charge is available. So that that is used to feedback, or if that battery, because in case of energy storage system, it is connected to the PCS, or you can say the inverter, where this DC is converted into AC and connected to the grid. So EMS or energy management system should know how much power is available with that battery bank, or how much power can be generated for how much time. Let's say 100 kilowatt hour of data is available in the battery pack. So this EMS will understand now he can supply 100 kilowatt hour of energy to the grid. Now let's say grid is demanding 10 kilowatt hour energy. So it can compute, and it will give that command to the grid operator that yes, this 10 kilowatt hour power I can give you for 10 hours. So that is how this EMS functions and communicate with the external world, or you can say the grid, with the communication with the grid. It will help that EMS to communicate with the grid also. So again, it is important from the data available in the battery. So battery data is communicated to EMS. EMS will again communicate to the grid. So where again, grid will have their own integration with multiple resources, and they will try to uh, I mean, the again smart management is required at the grid side also. So they are again trying to get from where power can be taken, how much power can be taken. So all that algorithm or that calculation is it is supporting to the grid level also. Uh, for consumer devices, again, it is the real-time data is required at the display. In case of your mobile, the battery charge is always denoted on the topmost corner of your mobile, so that you will come to know how much charge is available in your battery of the mobile, or how much time you can use your mobile, whether the charge is sufficient to take all the calls for whole day, or you need to charge your mobile. So that information you can understand from the display of your mobile. So all these communications are very important from the different application point of view, and the all these communications are done by VMS only. Now, battery data transmission, again, we gone through all these things. On canvas, SOC data is given to the vehicle. Then for charging, this is in detail for the EV only we are discussing here. So from the transmission point of view, the SOC SOH data is given to the VCU on the canvas. From charging point of view, the whatever communication is given to the charger, it is to coordinate the charger so that your batteries are getting at the required voltage and current. It is not exceeding the voltage for the charging. So safer limit of your battery pack will be communicated to the charger. And then user feedback also. Once your charging is completed, you will come to know your batteries are now fully charged. You can disconnect your charger. So all these informations are important from the EV point of view. So uh, the battery data transmission, it is in the case of running of vehicle. Charging coordination, it is during the charging of your vehicle, and user feedback is again, it is the real time data communicated to the user, right? So we try to understand the communication part of your BMS. So whatever the blocks we saw here is the communication part, the computation part, then the measurement part, now the cell balancing part. This is very, very important. So thermal part is again important, which we discussed. Now the cell balancing. What is cell balancing? We'll try to understand what is cell balancing. What are the importance of the cell balancing into the battery pack? Okay. So this is the last topic of our session. So cell balancing is why it is required, first of all. I hope you understood what is cell balancing, first of all. So cell balancing is nothing but uh, a process of balancing all the charges, or you can say the voltage level of all the cells inside the battery pack. So it is balancing, or you can say bringing to the same level of all the cell charges, right? So that is the cell balancing. Now, why it is required? So voltage imbalance among the cells can lead to overcharging or undercharging of individual cell, or reducing the performance and safety of the battery pack. So just to avoid all these things, we need this cell balancing. So just to understand it, I'll try to explain this here. Let's say battery pack is for just for understanding. We'll make it battery pack of two cells. Okay, two cells are connected in series. Let's say uh, so one cell is having charge of 100%, and another cell is having charge of let's say 50%, and both cells are connected in series. And now I want to discharge this cell. So this battery pack, or the both the cells connected in series, will give me the maximum 50% of energy, because the cell 2 is 50% charge only, and cell 1 is, even though cell 1 is 100%, since another cell is going to at zero level after 50% of discharge. So whatever 50% energy is balanced in the cell 1 will not be utilized. So that way it is uh, the performance is getting reduced, even though I charge both the cell, but one cell got fully charged, another cell is half charged. So that's the reason I'm getting 50% of performance from the battery pack. Similarly, when cells are connected in parallel, scenario you can say same, 100%, one is 100%, another is 50%. And when load is connected up to 50%, I will get the full current from the battery pack from cell 1 and cell 2. So whatever current 1 and current 2 I am getting is the total current from both the cell. So after 50% of charge is finished from cell 2, only cell 1 will give the current to the load, but that is only the I1. So I2 is 0. So my total current will be 50%. So in case of paralleling, I will get 50% of performance from the battery after 50% of discharging. So in case of paralleling, again, the performance of your battery pack is reducing, But here it is still you can keep on getting the power from that another cell, because that cell is still alive and giving power to the load. But the current will be half, because one cell is dead, only one cell is giving you the power. So this is in case of paralleling. Now, this we try to understand from the discharge point of view. Now, in case of charging, again, we will go to the first scenario where both the cells are connected in series. Let's say now one cell is 100% charged, another cell is 50% charged. Now you have connected the charger. So in that scenario, your first cell, since it is fully charged, your charging current will get limited to the float current, right? So that's the reason your battery pack is not getting, you can say, at full rate current or full charging current, uh, since your first cell is blocking that charging current because it is already fully charged. So your second cell will get charged at the floating current rate only. So it will take more time. If maybe the expected, let's say, timing of 2 hours or 3 hours to get the full charge, it will take more than 12 hours because it is getting charged at the floating current only. It is very means less than the charging current. So it is in the range of 10% of your charge current. So 10 times your charging time will increase. That is the thumb rule I am saying. So in case of series, your again charging time will increase. In case of paralleling, again, since your first cell is fully charged, second cell is 50% charged, and now charger is connected. So in this paralleling case, one cell is not taking the current, but other cell can draw the current. But there is a chance of damaging of your cell, because whatever current battery pack is drawing, that is supposed to be divided in two cells. But since one cell is fully charged, another cell will try to take the full current. So the total current is going through that one cell, and it can damage that cell after over let's say some time, because you're charging that cell at double rate. So and you're supposed to charge, let's say, at 1 ampere, but you're charging at 2 ampere. So because of this high current, again, because your BMS is sensing only the input current, not the cell current. So BMS will allow 2 ampere current from the charger, but since one cell is fully charged, it will not draw any current from that 2 ampere, and remaining 2 ampere will go to another cell. So it will try to damage that cell over a period of time. So all these are the drawbacks of your cell imbalancing. So during charging also it will have the effect. During discharging also it will give you the bad performance. So to increase your performance, your all cells should be at same level. Then only your battery pack will give you the 100% of the expected capacity from it, or the performance of that battery pack. Now, how it is work? So there are two ways of balancing all the cells. So one is the very simple method, where it is the you can say the passive balancing we are saying. So whatever excess charge is there from other cell, it is that energy is getting dissipated into the dummy cell or dummy load inside the BMS or inside the battery pack. So let's say the first scenario where one cell was having 100% charge, another was having 50% charge. So the 50% of energy from first cell will get dissipated through the dummy load inside the BMS, and that will bring both the cell at 50%. So that is passive balancing. So the excess energy is getting dissipated as a heat or the power is getting lost. Another is the active balancing. So active balancing, it is like the whatever charge is there inside, that is 100% full charge C1. That charge, excess charge is stored, or it is that energy is stored into the capacitor or inductance circuit, and that inductance uh, I mean connected to the lower cell or C2 in this case, and that energy is getting transferred to C2. So from one cell, that capacitor is getting charged, and from other cell, it is getting discharged. So this way, the energy is getting transferred from one cell to another cell, and both the cell are trying to be at one level, so that here the excess energy is not getting wasted, but it is used to charge the other cell. So maybe after this balancing, you will get the 75% charge in both the cell. In earlier case, the total charge was 150. So 50% is getting wasted. So your total charge is 50% only. But in this case, it is total charge is 75% because you are not wasting any charge here. So 100% from one cell, 50% from another cell. So that 50 out of that 50, 25% is uh, getting charged by the capacitor and dissipated into another cell. So that 25% of energy is getting cumulatively into the other cell. So total pack capacity is getting increased by 25%, right? So the active balancing is more efficient, you can say. It is not giving any power losses, but because of the complex nature of this circuit, uh, it has not been used in EV, but in energy management, energy storage system, we are using this active balancing most predominantly, because there we cannot afford to lose the excess energy from as a heat inside the battery pack. Now this is the pictorial form where I'm trying to explain you whatever I told you just now. So here four cells are shown with some SOC level. So cell 4 is 100% connected. Cell 2 is let's say 50%. This is maybe 60%. This is maybe 70%. So these are different levels of charge inside the cells. So this is the real picture before balancing. So then, with the help of passive balancing, what BMS will try to understand is which cell is having the lowest charge. So it will understand cell 2 is having the lowest charge. So BMS will try to dissipate whatever extra energy of other three cells. So if you draw a vertical line here, so whatever is above this line, it will get dissipated as a heat into the dummy load which is available inside the BMS. So whatever extra energy, or you can say the imbalance energy, which will get dissipated into the dummy load. So dummy load is connected across each cell through a MOSFET. So that MOSFET will get turned on wherever that extra energy is there. So that's how we are dissipating that energy, excess energy from the cell, and bringing all the cells at one level. So it will help you in getting this battery pack 100% charge, or whatever charge is available inside, you can use that for discharging purpose also. So the major advantage is in case of charging of all these cells. So discharging anyway, it is giving you this much energy only, total energy. So whatever is left, that will be inside the cell only, but you cannot use that cell because cell 2 is already been maybe reached to your 0%. So you cannot use that remaining energy. But uh, if you dissipate that energy, excess energy inside the load, it will benefit you during the charging of your battery pack. So next time when you are charging or trying to charge your battery pack, it will get fully charged, 100% charge, not like only 50%, or if this is 100%, then nothing will get charged. So this will remain the status quo. So your battery condition will be like this only, because one cell is already there fully charged. So it will not allow other three cells to get charged. So to avoid that, we have to dissipate this energy. We don't have any other choice if you want to get the better performance from the battery pack. Now, the active cell balancing. So here again, whatever the energy is there inside the cell. So as I said, let's say this cell 4, here a capacitor is connected. All whatever energy is there, it is getting dissipated into that capacitor. Then that capacitor will be connected across this cell, so that whatever charge is given to the capacitor, it will get discharged into this cell. So it will try to charge from this cell and discharge into this cell. So this is how this charge is getting transferred from one cell to another cell. Similarly for this cell also, because again BMS will try to understand which cell is having more energy, which cell is having low energy. So it will try to uh, transfer that energy from one high cell to low cell. And here it is time requirement is less, because it is only smaller energy has to be transferred from this to this. So this is again this is active balancing. Now if I draw a vertical line here, you can see this the charging level for the same condition. The charging level of this battery pack is maybe around 30%. But here in this case, once all these four cells are balanced, it is more than 30%, or in the range of 50 to 60%, you can say. So whatever extra charge is there, that is not wasted in this active balancing, right? So I hope this session is informative, and you people are not bored with this kind of one-way communication. So I think I'm at the end of this session now. So thank you all for being with me, bearing all this one-way communication. So here we will try to take your now the questions, so that we will try to understand whether you understood properly the functioning of BMS, and the key functions, the protections, or the cell balancing. Any queries, if you have, we have sufficient time now today, because I was a little bit fast, I think. So I can take all your questions if you have any doubts. I have shared my contact detail as well, my email ID as well. You can share your queries if you have in future as well. Anytime you can share your queries. I'll be happy to answer, or try to answer your queries. If not possible immediately, uh, maybe in a day or two.
Dear participants, if you have any queries or question, you can ask. First, unmute yourself, then ask the question.
or if you want, you can send on the chat box also.
Sir, good evening, sir.
Yeah, good evening, Mr. Vir.
Yes, yes, sir. Myself, Dominic from SRM-ISD. I have a
Yeah, Mr.
question
Dominic.
about temperature measurement, sir. Okay, how
Yeah,
many temperature sensor is advised for medium level battery packs, sir?
yeah. So the number of sensors generally depends on the application of your battery pack. In case of EV, where the battery packs are in the mobile condition, or it is always moving along with your vehicle. So there, when we design the battery pack, we try to understand the critical cell positions. So the cell which are having the cooling air, maybe if your vehicle is moving, some air is always going inside the cell. So the cell which are near to this inlet of air, we don't need to monitor that cell because they are always cooler than the cell which are not coming directly into the airflow. So there it is must to monitor the temperature of the cell which are not having the cooling compared to the cell which are near to your the inlet of air. So we try to use that as a I mean, you can say the reason of reducing the number of cell sensors into the battery pack. But in case of base or battery energy storage system, where the complete pack is inside the container, where all cell, nothing is accessible or nothing is exposed to the air or cooling area, there it is means advisable to monitor the temperature of all the cells, because we cannot predict which cell is going to get damaged or which cell is having more temperature, because any cell can go to high temperature because of maybe inherent issue of that particular cell, or any maybe because of this whatever balancing circuit we just discussed. So because of that also cell can function in a different way, and its temperature can go haywire. So to understand the individual cell performance, we need to monitor the temperature of all the cells. So again, as I said, it depends on the application and how that cooling system is used inside the battery pack. I hope I answered.
Yes, sir. Thank you, sir. Yeah. Yes, sir. Thank you, sir. Thank you for your explanation. I
Thanks,
understand
Dominic.
clearly. But in practical condition, we found they are using one or two sensors only. Okay. Any possibility to increase the number of sensors? Can we reprogram our BMS? Likewise, anything it is possible. Any
See,
programmable BMS are
again,
available.
yeah, programmable BMS are available. The
Okay.
only case is you need to have the number of sensors, because if you want to monitor, let's say, all the cells, you need that many sensors are must. Maybe programmable BMS will take one sensor at a time inside, but again, you need a multiplexer there to take all the data, and then at a time one data will be given to BMS, the reader, and then it will try to store all the data one by one. So again, system is getting complex. So it depends on whether it is required for that particular application, or you can take a bold decision on the basis of your maybe the critical. If I don't know whether you have seen the battery pack. Let's say a complicated battery pack is having cells all around into the enclosure. the cell which are into maybe in center will have heat from all other adjacent cell also. So the center one cell will have more temperature. If you monitor that cell temperature itself, will give you an rough estimation that whether your battery pack is performing at the means 100% efficiency or it is having any issues. So from that also you can understand. Uh, you can allot some sensors maybe nearby cells so that maybe alternatively because that heat of adjacent cell is already there in the that sandwich cell. So you can what you call maybe optimize your number of sensors depending on your layout of your cell, how you have placed all the cells inside the battery pack. Yeah, in chat box I got two.
Thank you, sir. Thank you.
Yeah. So one query from Vivek is, can BMS be integrated with lead acid batteries? Uh, okay. Lead acid batteries, I can integrate the BMS, but uh, we are not using as such the BMS for lead acid. But yes, of course, if we can use that BMS for lead acid, it is always better in case of let's say a battery bank of UPS or some other application where number of lead acid batteries are more connected in series and parallel. So that again can be used for lead acid as also. But in UPS, that system is already there to protect the overall bank, not the cell level. So battery level, we are not protecting it. But let's say a UPS of 48 volt battery. So it will protect the overall battery, not the cell. But if you have the BMS, yes, it can be useful. Another question is from Karthik Kannan. In active cell balancing, let's consider one cell, one has 50% SOC, remaining two cell, three cell, four having 80%. My question is that cell one is charged by which cell? Either two, three, or four. Otherwise, combined. Okay, good question, Karthik. So here, see, now this one cell you said it is 50% charged. Another three cells are at 80%. So now you have to take means charge from each cell. Means maybe from cell number two, some charge will be taken given to the cell one. Again from three, it will be given to one. Again from four, it will be given to one. So the BMS will try to do it at a continuous period until all cells are bringing at one SOC. So in this case, if your average is coming out 80 into 3 plus 50, so the average is 72.5. So that is how the BMS is working inside. So unless all cells are at 72.5% of SOC, it will try to transfer the energy from one cell to another cell until all cells are bringing or brought at 72.5% of SOC. Right. Another question, same from Karthik. In passive cell balancing, let's consider cell 1 as 10%, remaining 2, 3, 4 at 80, 90 and 90%. Now, what will happen? Okay, so in such scenario, first of all, this kind of scenario will not happen in the battery pack because the energy level what you have shown here, or I also shown in my example, that will never happen, because one cell is at 100%, another cell is at 0%. It will happen only when your cell is having some issue, either it is open circuit or some issue with the cell itself. So if it is continuously happening, then that pack won't work. It will go to service center. We have to diagnose the battery pack, replace that faulty cell, and make that battery pack again to the required level. So that is the standard protocol we are following. But since it is an example, here what I can say is, if it is the ideal condition or it is the real condition, in that case, whatever excess energy of other three cells, 80, 90, 90. So 70% from cell 2, 80% from cell 3, 80% from cell 4 will get dissipated as a heat to bring all the cell at 10% level. So the program in the BMS is like that only. But it will not dissipate that much energy, because if you want to dissipate 80% of your losses or charge into the dummy load, because first of all, that dummy load is not designed for this much energy to be dissipated. It is just to dissipate only 3 to 5% of energy imbalance. So that is the practical way of designing, I'm saying. Otherwise, theoretically, yes, we can discuss any level. We can discuss on pros and cons. Then what time will take to discharge that much energy? What is the capacity of your cell? So all these parameters you have to consider, and then we can we will when you design the balancing circuit, you will come to know whether this much energy can be discharged, right?
Good evening, sir.
Yeah, good evening.
Sir, considering one or two cells are defect in
Huh,
the battery pack,
right.
we need to somehow we have identified, we diagnosed those cells. We want to detach those cells and we need to remake the battery pack. So during the same thing happened in our lab, and we tried detaching that, and we found it is very difficult. So, is there any easy way to do that, sir?
See,
Removing the cell. Sir, tell me.
yeah, yeah. So first of all, if your cells are welded, then it is very difficult to detach it and reuse it.
Yes, sir.
So that we are not recommending to do the repair work in case of welded cell. So to make it maybe user friendly, or to reduce the repair cost, what we are doing in our design is, we are means making that particular battery pack into different modules, and
Okay, sir.
then that modules are connected in series and parallel. So instead of changing that complete battery pack, your cost will get reduced to change of that particular module only. So let's say a battery pack consists of 100 cells. Okay. And if all are connected in series with some maybe welding of the bus bar, so instead of wasting all the 100 cell, what we will try to do is we'll make module of, let's say, 10 cell. So
Okay,
all
sir.
10 cell can be connected in series with some flexible bus bar, which can be disconnected and connected with new module. So instead of wasting all the 100 cell, you can just replace that module of 10 cell. So that is how we are following in case of welded bus bar. But in case of the bigger cell, the prismatic cell of let's say 100 AH or 200 AH, the tappings are there onto the terminal itself. So you don't have to do the drilling, this welding of that cell.
Yes, sir.
So that is the easy way of having the. So in case of bigger capacity,
Okay.
your cells are not getting wasted. You can just replace that faulty cell. Just
Okay.
you have to remove the screw, remove
Yeah.
the cell, and you can use it.
Thank you, sir. Thank you, sir.
So any other questions from chat box? Sahu has asked, can we replace a particular weak cell during maintenance by monitoring? And I hope the same answer what I gave it to Balaji. Yeah. Any other queries?
Sir, good evening, sir. How to identify fault with the BMS? Suppose the
Uh,
BMS itself has undergone some fault. How to identify it?
okay. Okay. Good question, doctor. If that BMS itself is faulty, means either it will not give load to your battery, your load, battery will not get discharged, or in case of charging also, battery will not get charged. So that is how you can, understand whether your battery pack is having any issue. Either it can be with the battery or it can be with the battery pack. So that battery pack as a whole box is black box for the user, right? So if your batteries are not getting charged or discharged, then you will come to know that your battery pack is having the problem. But when you open that battery pack, then only you will come to know what is there inside. So whether it is a cell issue or the BMS issue, so unless you open it, you analyze what exactly there inside. So in some battery packs, we are having fuses also inside. So even though your BMS is working, your battery will not get charged or discharged. So in that case also, as a pack, the batteries are not working. So the easiest way to understand BMS problem is communication. If it is not communicating with any external system, then you will come to know that yes, your battery pack is not working.
Thank you, sir. Thank you.
Thanks.
So I think there is no question.
Okay, so we'll take off now.
No, sir, one question is in the chat box.
Yeah, Dr. Kannan, instantly battery getting full charge but not discharging. So this, as I discussed during the balancing of the batteries, if your battery one cell is fully charged and other cells are not at the level, so your battery pack is not getting discharged and not getting charged also because of that one cell is having fully charged. Since other cells connected in series are already discharged, so that's the reason you'll neither charge the battery pack nor discharge the battery pack unless you replace that cell, faulty cell. Either your battery pack should get balanced itself with the help of BMS. Maybe it will take some more time. If it is the difference is more, as I said, the ideal difference what we are predicting is under 5% of imbalance. If that imbalance is more, as query from I think Kannan Karthik has asked, if that situation comes, your battery pack will take more time to get it balanced. So either you have to wait or you give that battery pack to the service station. They will identify the faulty cell. They will replace it. and then only your battery pack will perform to the expected level. Any other queries?
Thank you, sir. Thank you for your this session.
Thank you, Dr. Mrinal, for giving me this opportunity to interact with
Sir,
all
in
you guys.
future, we are planning for physical mode.
Thanks a lot, because it is required. Unless you interact while session, we'll not come to know whether you are understanding or not, because
With
this
hands-on
is
data.
one way kind of communication we are doing. But hope whatever way we connected, it was useful. Since queries are not there, either you understood it fully, or I'll say not understood anything. But since queries are coming now, so I can say yes, you understood. I think little bit whatever way I tried to present. Yeah, thank you all for your patience in listening and trying to grasp whatever I was telling to you guys. Thank you once again.
Sir, good night.
Thank you. Good night.